Okay, writing and graphing inequalities. So we've gotten done with adding, subtracting equations, solving those, multiplying and dividing equations, solving those, writing inequalities, and now we're going to practice that with word problems and graph them. Just a reminder what the different symbols mean. Remember, this is less than. This one would be less than and equal to. And greater than, and then greater than, and equal to. Okay, so those are good to remember which way that they go, because I know sometimes kids struggle with that a little bit. Okay, so writing and graphing in real world problems. So this is how this works. Let's look at our first one in your packet for lesson 34. It says Caleb has at least $5. Okay, at least $5. So I know we can call it X, we can call it C for Caleb, it doesn't really matter. Let's say C for Caleb and $5 at least. At least means he could have more than $5. So if Caleb could have more, that would be greater than, and then at least he could just have $5. So it could also be equal to 5. So we write Caleb has greater than or equal to $5. To graph it, we find our 5. Because the symbol says greater than or equal to, we put a filled in circle. If it was plain less than or greater than, we'd have an open circle. But because it's equal to, we fill it in, and then we draw our arrow to the right, because C should be greater than 5. Let's try the next one. Tarek has more than $5. All right, I can call him Tarek here, $5. Same thing. More than means it's going to be greater than. It doesn't say he has 5, it has more than 5. All right, so that indicates to us when we graph it, it's going to be an open circle because it's more than, and it's going to go to the right, like that. So those are the two different graphs you might have for greater than or equal to, or just greater than. Let's keep trucking. Vanessa has at most $5. All right, we got Vanessa, we got $5 again. At most, that means she can't have more than that. She could have $5, so it could equal $5, but she can't have more, so it's going to be less than or equal to $5. Because it's less than or equal to, we go to our 5, we fill it in, and it's less than, so this time we're going to go to the left. Okay, moving right along. Yu Chen has less than $5. So we'll go with Yu Chen, $5. Less than, well, it's just how it says, less than $5. Doesn't have $5. So again, when we graph it, it's going to have an open circle, and it's going to go to the left because it's less than 5. So those are examples of how we'll take a statement, turn it into an inequality, and then turn it into a graph. So that's first example. Here's a second example. Kelly works for quick oil change. If customers have to wait longer than 20 minutes for the oil change, the company does not charge them for the service. The fastest oil change that Kelly has ever done took 6 minutes. Show the possible customer wait times in which the company charges the customer. Okay, if they wait longer than 20, then it's free. The shortest one is 6 minutes, and we have to show all of the wait time that could be possible. So down here, I think I'm going to put wait time. And we have to really think through this. Show the possible customer wait times in which the company charges. Okay, so they're going to charge the customer as long as it's under 20. So they would charge them for 4 minutes, 6 minutes, 8 minutes, okay? 10 minutes, 12 minutes, 14, 16, 18. They would charge them for 20 minutes, but anything over 20 minutes, now it's free. Okay, so I'm going to put, I know it's 20 minutes, so I know that it's going to have to be less than or equal to 20 minutes, okay? Because if it's 20 minutes, they still charge me, and if it's less, they charge me. So on 20, I'm going to put a filled in circle, and I'm going to draw my arrow. Now that it says Kelly, the fastest that they've ever done is 6 minutes. So this time I'm going to draw my arrow specifically to 6 minutes. Could be less. Maybe they have a really, really fast day, but because it mentions 6 minutes, I'm going to go ahead and put it in there just like that. And we're going to show that the wait time would be less than or equal to 20 minutes. All right. Example 3. Let's try this one. Gurnaz has been mowing lawns to save money for a concert. Gurnaz will need to work at least 6 hours to save enough money, but he must work less than 16 hours this week. Write an inequality to represent this situation and then graph the solution. Okay, so this one kind of sounds like I have 2 inequalities in there. He will need to work for at least 6 hours. All right, so here's Gurnez. 6 hours, at least 6. He could work more than 6, so Gurnez could work more than, but he has to work at least 6. So that is my first inequality statement. The other one says he must work less than 16 hours. Maybe there's a cap. Like if you're a certain age, you only can work so many hours. That's sometimes kind of called a labor law. So there, he's also got that inequality. So Gurnez can only work less than 16 hours. All right, so he has to do that, and he has to do less than 16. More than 6 or equal to less than 16. What does that look like when I graph it? Okay, well, let's do this. First, I'm going to find my 6, and it's a greater than or equal to, so I'm going to color it in, and I know my direction is going to go to the right. Okay? I also have G is less than 16. Gurnez has to work less than 16. So that's going to be an open circle on 16 because it's less than. And it has to be less than 16. Well, if this one has to be less and the other one has to be more, that means I can connect the line. So the graph is actually going to look like this. This is the sweet spot, the amount of time that Gurnez will work somewhere in there in order to get enough money for his concert. All right, so we took some statements and graphed them. We took a couple of word problem examples, and now it's going to be time to try it on your own. Flip it over to the back side. Here are some exercises. I want you to give 1, 2, 3, 4, 5. Go ahead and pause this video, do 5, and then come back, and then I'll show you what the solutions should be. But first, give them a try on your own. Okay, hopefully you've given these a shot, and hopefully we're just going to check your answers and you're on the right track. Let's see what they're asking us here. Write an inequality, represent the situation, and then graph it. Okay, Blayton is at most 2 meters above sea level. I'm going to use a B for Blayton, and it's 2 meters, so I know I'm dealing with 2 meters, and it's at most. If it's at most, it means it can't be any more than 2, so it has to be less than that, but it could be 2 meters. So it will look like that. B is less than or equal to 2. I'll find my 2 and color it in because it's equal to. And then I'm going to go to the left with my arrow. Number 2, Edith must read for a minimum of 20 minutes. Let's use E for Edith. Doesn't matter the variable you use. We got 20 minutes. And it says she must read for a minimum. Okay? She could read more than 20. So it could be greater than 20. Or it could just be 20. So a minimum of 20. So it'll look like that. E is greater than or equal to 20. And I come over to my graph and I find 20. And I'm going to fill in the circle. And it's greater than, so it's going to go to the right. All right, moving on to number 3. Travis milks his cows each morning. He has never gotten less than 3 gallons of milk. However, he always gets less than 9 gallons of milk. All right, this sounds like 2 inequalities in here. So we've got T for Travis. He has never gotten less than 3 gallons. 3 gallons. He's never gotten anything less than that. So that means he gets more than that, or he gets that. Gets more than that, or he actually gets 3. And it says, however, and he always gets less than 9. Okay? Travis, 9, he always gets less than 9. It doesn't say he gets 9, it's less than. So those are my 2 inequalities now to graph. So first I'm going to find the 3, color it in because it's an equal to. And I know it's greater than. And then I also have 9, which is open because it's not equal to. And it's got to be less than that. So that means my graph is going to connect like that because it's an and inequality. Number 4, Rita can make 8 cakes for a bakery each day. So far, she has orders for more than 32 cakes. Right now, Rita needs more than 4 days to make 32 cakes. All right, so this got a little extra information in it, but we know Rita, 8 cakes a day. If she does 8 cakes a day and she has orders for more than 32 cakes, she's going to need 4 days for that. All right, so more than 4 days. So let's put the 4, that's the number we need. And she's going to need more than 4 days. Rita's going to need greater than 4 days. And let's see. So far she has 32. Right now she needs more than 32. Because it says more than, we aren't going to put equal to. We're going to just put more than. We assume 32 divided by 8 is 4, so it could be equal to, but we have to go with the wording, and it does say more than 4. So we're going to leave it like that, and we're going to find our 4. We're going to leave it open, and R has to be greater than. Okay? I know it's a simple math problem. If she doesn't get any more orders, she should be able to get it done in 4 days, but we also have to look at the math language. How about number 5? Rita must have all the orders placed right now done in 7 days or less. How will this change your inequality and your graph? All right, we already know that Rita needs more than 4 days, but we also know that Rita is going to she has to get them done in 7 days or less. So it has to be less than 7, or it could be 7. So now we not only have our open circle at 4, we also have a closed circle at 7, and this way has to be greater and this way has to be less, so our graph looks like that. All right, hopefully those did well for you. Now, the extensions. A few more problems I want to try on your own. This one maybe gives you a couple extra math steps to do. I don't think you'll have too much trouble with them. So go ahead and pause the video, and you're going to work on 6, 7, 8, 9, and 10, and then you can come back to me and we'll work on the last one. Okay, you're back. Hopefully we did these okay. Let's take a peek. We'll start with number 6. Casey has been mowing lawns to save up money for a concert. He earns $15 per hour and needs at least $90 to go to the concert. How many hours should he mow? All right. He earns $15 an hour. He needs $90. Well, if he needs $90 and he makes $15 an hour, how many times 15 go into 90 to figure out how many hours? 15 goes into 96 times. So he's going to need to work 6 hours for 90 bucks. Now let's look at where the inequality comes in. He needs at least 90. Okay? He needs at least 90. So that means 6 hours. Casey, 6 hours. He has to work at least 6. He could work more, which could be greater than, but he has to work 6 hours. So we write it like this. Casey has to work more than or equal to 6 hours. We go to our 6. We fill in the circle because it can equal that. And it has to be greater than. So we're going to the right. Next problem, number 7. Rachel can make 8 cakes for a bakery each day. Oh, kind of like the last bakery one. So far, she has orders for more than 32 cakes. How many days will it take her to complete the order? Okay, so she's got more than 32. If she had 32, 32 divided by 8 would be 4 days. Okay, so we've got Rachel, and we got 4 days here. But she has more than 32, which means she's going to need more than 4 days. If she needs more, it's going to be greater than 4 days. It can't be equal to 4 days because she has more than 32. If she had exactly 32, it could be that, but she has more than. So inequality is going to look like that. We're going to go to the 4. It's going to be an open circle, and R has to be greater than that, so it's going to go to the right. Number 8, Ranger saves $70 each week. He needs to save at least $2,800 to go on a trip to Europe. How many weeks will he need to save? All right, $70 a week, and he needs $2,800 at $70 a week would end up, I can cancel my zeros out there, $40. Or 40 weeks, excuse me. He's going to have to work 40 weeks for $2,800. So let's see. Here's Ranger. Here's 40 weeks. But let's look at the inequality wordage. He needs at least $2,800. If he needs at least, it means he could get more than that. If he got more than that, he'd have to work more than 40 weeks. So he could work more than 40. At least means he also could get exactly that amount. So that's an equals to. So we go to the equation or the number line. We'll find 40. We'll fill in the circle. And R has to be greater than that. So he has to work more, equal to or more than 40 weeks in order to save up enough money. Number 9. Clara has less than $75. She wants to buy 3 pairs of shoes. What price shoes can she afford if all the shoes are the same price? So we assume they're all the same price. She's got $75 and she wants to buy 3 pair. Okay, so if $75 divided by 3 will be $25 for each pair of shoes. Okay, so we know Clara and we know that it's $25 for each pair of shoes. Let's look at the inequality wordage. She wants to buy, let's go back here. She has less than 75. If she had $75, she could buy, or she could spend $25 a pair, but she can't spend $25 a pair because she has less than that. So if she has less than 75, she might have 74. We don't know how much less, but she has something less. So the number the amount of shoes that she has to have is going to have to be less than $25. We don't know how much less. It's just going to have to be less than 25 because she has less than 75. So it can't equal that. To graph it, we go to 25. We get an open circle. And C is going to have to be less, or Clara's going to have to spend less than 25 bucks a pair. And number 10, a gym charges 25 bucks a month plus $4 extra to swim in the pool for an hour. If a member only has $45 to spend each month, at most, how many hours can they swim? Well, if the member has 45 bucks and it costs $25 just to be there, that leaves you an extra 20 bucks. Okay? Out of that extra 20 bucks, $4 extra each hour. And they're asking how many hours. So if I take that $20 and I divide it by $4, I would end up with 5. So 5 times, basically, he could do the extra swim if he'd like. All right, so this member, we'll go with M, can go 5 times, but let's look at the wordage now. They only have $45. What's at most, how many hours could they swim? The very most they could do is 5, but they can't do any more than that. So they could go less than 5, and they could actually do 5. So that's less than or equal to. Go to the graph. We find our 5. We draw our circle and color it in because it's an equals to, and it's a less than. So it's going to go to the left. All right, well done. That concludes our practice. And now I'm going to have you stop, and you're going to go do the problem set for homework.